Subscribe this channel and press bell icon to get notification for latest and informative videos before anyone. Limit state design philosophy aims to attain the basic objectives of the structural design to ensure safe, serviceable and economical structures. However, the real excellence of the limit state design philosophy lies in defining, clarifying how these objectives are to be achieved. Towards this, it re-examines the process of design and re-evaluates the margins of safety employed to cover uncertainty and ignorance of the structure's function and its performance in reality. In this video, I will try to explain the philosophy of limit state design, why it is important in structural design, the principle of it, different types of it, the advantages of the limit state method, and many more things related to it. I am Chirag and you are welcome to this channel. Let's learn something. The limit state method recognizes that in a structure, a limit state may be reached as a result of the influence of several random factors affecting safety and the serviceability, such as the variations in the imposed loads and the strength of material of the structure is composed, as well as the lacks in the methods of analysis, design and the construction. These variations can only be expressed in terms of the probability that the structure will not reach at the limit state. Design calculations must therefore aim at keeping the probability of a limit state being attained below a certain value previously established for that particular structure. Now let's go ahead and look at the classification of limit states. The principal limit states to be considered in the particular structural design and the conditions to which they correspond are mainly the limit state of collapse and the limit state of serviceability. Let's understand it one by one. A limit state of collapse, which is also known as the ultimate limit state, are related to the maximum load carrying capacity of the structure. The usual design for the strength of sections either in flexure, shear or the torsion therefore corresponds to this limit state. The usual conditions under which the limit state may be reached and those conditions are loss of equilibrium of a part or whole of the structure. It may be a failure of critical sections of the structure. Transformation of the structure into a mechanism, maybe a plastic mechanism. Buckling of structure due to the elastic instability and the fatigue problems. Another one is limit state of serviceability. These are related to the criteria governing normal use of the structure, the principal serviceability limit states and their significance in different substates. Now if we talk about those substates, then number one in that is limit state of deflection. The deflection of a structure or any part of the structure should not adversely affect the appearance or efficiency of the structure. Excessive deflections may lead to wider cracking of non-load bearing members, partitions and finishes. Maybe ill-fitting doors and the windows, poor drainage, misalignment of the sensitive machinery, etc. and may cause discomfort or alarm to the users of the structure. In that, number two is the limit state of the cracking. You can also name as a state of local damage. In this state, excessive cracking, excessive that means the wider cracking, might mar the appearance of the structure or lead to corrosion of steel, impairing the durability of the structure. It might thus entail severe maintenance problems. Cracking is not dangerous, but the width of cracks should be limited in order to avoid the aforementioned effects. Other examples of local damage are sparring, localized yielding or buckling and the splitting. And the next is limit state of vibration. Excessive vibration, it can be near to the resonance, can cause severe damage and interfere with the proper functioning of the structure. Where there is a likelihood of the structure being subjected to a vibration from causes such as wind forces or the machinery, measures should be taken to prevent the discomfort or alarm or impairment of its proper function. Up till now, we talked about major limit states, but in addition to the major limit states, in special cases, the structure may have to be designed for other criteria or the other limit states. Let's understand about few more considerations or the limit states. And the first one here is overall stability of the structure, or it can be also known as robustness. The general arrangement of the structure and the connection of its various members or the elements should be such that as to give the structure appropriate stability and robustness. In particular, there should be a reasonable probability that the structure will not collapse catastrophically, that under the effect of misuse of the accident like the explosives or the impact of the heavy bodies. Disregard to that for the effect of impact has resulted in a progressive and the catastrophic collapse. Next to that is the fire resistance. Fire is an accidental hazard during which it is necessary to ensure the carrying capacity and the integrity of the structure for a defined period of time. And last but not the least, an important one is the durability. The durability of a concrete refers to its ability to resist the deterioration from the environmental conditions. Satisfactory durability can be achieved by paying specific attention to material specifications, quality control of the concrete and the workmanship, and by taking adequate steps for protection and routine maintenance wherever it is necessary. As a concluding remark, I tell you all relevant limit states should be considered in the design to ensure an adequate degree of the safety and serviceability. In most practical cases, however, one may design the structure based on the most critical limit state and then check that the remaining limit states are not reached. Normally, the ultimate limit state due to the failure of critical sections is one to be designed for. However, other limit states or the conditions may be critical in certain cases, like buckling in slender members, cracking in liquid retaining structures likewise. For the usual type of structures, only three limit states need to be considered in the design, and that is number one is collapse, number two is deflection, and number three is cracking. So dear friends, hope you like this video. If yes, give thumbs up and try to share it. If you know other limit states other than this, do comment in the comment box. Let's meet in the next informative and exciting video. Till then, goodbye and take care.